Today we're going to talk about how to factor simple quadratics. This is section 13.3, day 1. The objective is students will demonstrate how to factor simple quadratics equations with 80% accuracy on a quiz. So if you're watching this online, the quiz that you should have taken would be during class, at the end of our class. So yesterday we learned how to multiply polynomials using the FOIL or Garden method. What does FOIL stand for? Remember, we're going to see this again on something very important. So let's remember, it's first, outside, inside, last. And this tells us the order that we can distribute when we multiply two binomials together. So let's practice using the FOIL method on these four equations. So if I multiply the first, I get x squared. Then outside would be x times 6, so plus 6x. Inside would be 1 times x, plus x. And last would be 6 times 1, so that would be 6. And then I always have to combine my middle terms. So x squared plus 7x plus 6. I'm going to put a box around this one. We're going to do the same thing for number 2. So first would be x squared. Outside would be negative 6x. Inside would be negative x. And last would be a positive 6. So I would have x squared minus 7x plus 6. Now notice as we're going along that this answer is quite a bit like this one. The only thing is the difference of a sign right here. And you can notice the signs up here as well. I want you to start making a connection here. So let's try number 3. First would be x squared. Outside would be 3x. Inside would be 2x. And last would be 6. So this time I have x squared plus 5x plus 6. And then the last one, I would have x squared. The outside would be negative 3x. Inside would be negative 2x. And last would be positive 6. So I have x squared minus 5x plus 6. Each answer that we found above, so we're looking at our answers here, those four answers, are in the form of a number times x squared plus a number times x plus c. We call this a quadratic equation in standard form. What do you think a, b, and c represent in the equation above? Well, they're just a number. So it's a number a, which doesn't make any sense to say a number a in math, but it's a times x squared, b times x plus c. So they are just numbers. We're just going to put numbers right here. Remember that c is a constant because it is not multiplied by a variable and is therefore constant. Math actually does make sense sometimes. Today we're going to learn how to FOIL backwards, and we call this factoring. So in order to FOIL backwards, that means we have to go from this point, when we have an equation in a quadratic and standard form, to this one that's called factored form. So we have to go backwards. So I want you to see first, if we're doing this in class, we would be doing a group discussion right now, talking about how we can come up with a method to unfoil. But let's look at x plus 1 and x plus 6. That's our first problem. And the answer, x squared plus 7x plus 6. Is there any kind of pattern that you can recognize? If we notice 1 and 6 here, if we add them together, we get 7. If we multiply them together, we get 6. What two numbers can I multiply together to get 6 and add together to get 7? That's 1 and 6. Does this question sound familiar? Well, it should. We've been doing it all first term. Look at x plus 1 times x plus 6, and the answer x squared plus 7x plus 6 again. Now do you see it? Now let's notice on 2, 3, and 4, do they follow the same pattern? Well, if I add -1 and -6 together, I get -7. If I take -1 and -6 together, I get 6, a positive 6. Let's look at number 3. If I add 2 and 3 together, I get 5. If I multiply 2 times 3, I get 6. Now, let's see if it follows true with number 4. If I add -2 and -3 together, I get -5. And if I multiply -2 times -3, I get a positive 6. So it worked in all 4 of those equations. So what general conclusion can you make about the method of factoring simple quadratics? Well, I just want you to think about this in your head and put what I just said in your own words. And you can pause the video to do that for just a minute. All right, let's practice 1, 2, 3, and 4, just to kind of get a hang of it. What are 2 factors of -16 that add to 0? Remember, factors are 2 numbers I can multiply together to give me this number. So I'm going to first take 16 and I'm going to make a factor tree. And everything I can multiply together to give me 16. I have 1 and 16. I always start with 1 and the number first. If it's even, I say 2 and 8, and I just kind of keep building. And then we would have 4 and 4. And I believe that's all of them for 16. And notice it said -16, but for just a minute I'm going to ignore that it's negative and just put all the factors of 16. Now the part that it's negative is going to come into play. I need to use 2 factors that I can make add together to give me 0, but multiply together to give me -16. That means one of them has to be negative. So if I look, 1 and 16, that's not going to work. If I have -16 plus 1, I get -15. If I have -1 plus 16, that gives me 15. So that doesn't work. Same thing with 2 and 8. I can get 6 or 10 or -6, but I can't get 0. So I'm going to cross those 2 off my list. 4 and 4. Now if I make one of these negative and one of them positive, then they would add together to give me 0 and multiply together to give me -16. Let's try 40. So 40, I would have 1 and 40, 2 and 20. I'm running out of room here. Would have 3 doesn't work, 4 and 10, 5 and 8. If you can think of any more right off the bat, I already know which one's going to work just looking here. 1 and 40, there's no way I can get 6. 2 and 20, there's no way. Now 4 and 10, I could get 6 by taking 10 minus 4. That would mean that my 4 is negative, my 10 is positive. So if I multiply them together, I do get a -40. So it would be +10 and -4. All right, number 3. If I take 81 and I list all the factors, I'd have 1 and 81. 2 doesn't work. 3 works. It would be, I know that's not the one I'm looking for, but 3 and probably 20-something. I think 27, actually. But I know I'm looking for 9 and 9. They need to multiply together to give me a +81, but add together to give me -18. That means they both need to be negative. So it would be -9 and -9. 2 factors of -4 that add to -5. Well, let's take 4, and we have 1 and 4 or 2 and 2. Those are the only numbers I can use. So I know I have to use 1 and 4. To get -5, I'd have to go -1 and -4. But if I multiply those 2 numbers together, I get a +4. So there's not any combination that would work for number 4. So we would call this, if we were doing quadratics, we'd say not factorable. Up to this point, you've just been writing on your homework, not possible. But it would be not factorable. Okay, so we're going to learn the actual method that we do to factor here, the simple factoring method. If I have a quadratic equation that looks like this, a number times x squared minus a number times x minus a number, c, then I would factor it like this. The first thing I would do is write 2 sets of parentheses like this and put my x's at the front. Because when I do FOIL and I multiply my 2 first numbers together, I need to be able to get x squared. So the first 2 numbers have to be represented by x. We're going to fill in the numbers using 2 factors of -8 they're going to add to negative 2. So if I fill in my chart down here, all the possible factors of negative 8, I'm actually going to just write them up over here. And I'm going to take 8 and list everything I can do. 1 and 8, 2 and 4, and that's it. And I'm trying to get negative 2 in the middle. So I know I'm not going to use 1 and 8. That's not going to help me get negative 2. But I know I can get negative 2 if I use those two. And in order to get that, I'm going to have to take 2 minus 4. So 4 would be negative and 2 would be positive. Once I know that it's positive 2, negative 4, all I have to do is fill it into this expression right here. So I'm going to go positive 2, negative 4. Now it does not matter if I put negative 4 here and positive 2 here. So you can write yourself a note here. Order does not matter. And that's all we do on this. Now I want you to think about this. How will I know if I'm correct? Is there a way to check your answer? Well, we can always check our answer by foiling. We can take x plus 2 times x minus 4, and we can FOIL it out. So we'd have first, which would give me x squared, outside, which would give me negative 4x, inside, which gives me 2x, and last, which gives me negative 8. So I have x squared minus 2x minus 8. And I look up here where I started, and I got the same thing. So I know my answer when I factored it is correct. So what numbers represent a, b, and c in x squared minus 2x minus 8? A lot of times I see people say the a is x squared. But a is actually the number in front of x squared, which is actually just a 1. B is the number in front of the x, so it's negative 2, and c is negative 8. So in general, when I factor, I'm looking for two factors of c, my last number, that add up to b, my middle number. So we're going to do a little matching down here. X squared plus 5x plus 4. We need to factor it and see which one of these matches it. So if I remember, my first step is to draw my parentheses, and I put my x's first. Now I just need to figure out what my other two numbers are. So I take my last number, c, and I take 4, and I make a factor tree. I have 1 and 4, 2 and 2. And I have to get a positive 5 in the middle. Well, the only way I can do that is if I use a positive 1 and a positive 4. So I'm going to go plus 1, plus 4. And then I just make sure it's on my list over here. It's right there, so I cross it off. Let's try the next one. I'm going to put my x first. Now I'm trying to get a negative 5 in the middle this time. I'm still using 4 as my last term, so I still can only use 1 and 4 and 2 and 2. So to get negative 5, this time I have to make negative 1 and negative 4. That's the only way to get a negative 5 in the middle. So I check over here, and that is one of my choices, so I'll cross it off. And then this one, this time I'm trying to get 3 in the middle. I still only have 4 to work with. So I can use 1 and 4 or 2 and 2. So to get a positive 3, I'm going to have to make 4 positive and 1 negative, because 4 minus 1 would give me 3. So I'd have minus 1 and then positive 4. And notice if I multiply negative 1 times 4, it gives me a negative 4 right there for my last term. And x minus 1, x plus 4 is right here on my list. So now I'm going to do this last one, x squared minus 3x minus 4. So I put my x's first. And if I'm trying to get a negative 3 in the middle, that means this time that my 4 needs to be negative and my 1 needs to be positive. So that when I add these two numbers together, I get negative 3. And when I multiply them together, I get negative 4. Alright, try the next one. Try to find the matching set on this side for the next one. And you can always check your answer, remember, by foiling it out, so you know if you're right or wrong. Okay, this one says identify A, B, and C. So on this one, A would be 1, B would be 8, and C would be 15. On this one, A would be 1, B would be negative 8, and C would be 15. This one, A would be 1, B would be 2, C would be negative 15, A would be 1, B would be negative 2, and C would be negative 15. So if I were to factor this one, since 15 is the number I'm trying to get on every one of these as my last term, I'm going to come over here and write 15 and make a factor tree. I can use 1 and 15, 3 and 5, and that's it. There's nothing else that I can multiply together to give me 15. So I have to get 8 in the middle, a positive 8. So I'm going to take a positive 3, positive 5. So it would be x plus 3, x plus 5. The next one, I need to get a negative 8 in the middle. So the only difference is I have to go minus 3, minus 5. And notice when I multiply a negative times a negative, I get a positive right there. This time I'm trying to get a positive 2. So I still only have 1 and 15 and 3 and 5 that I can use, but if I notice there's a difference of 2 between these two numbers. And since I'm trying to get positive, I'm going to take positive 5 minus 3. So it would be x plus 5, x minus 3. And then this last one, I'm trying to get a negative 2. That means this time I have to have a negative 5 and a positive 3. This last one, if I use 24 and I make a factor tree, I have 1 and 24, 2 and 12, 6 and 4, 8 and 3. Might have missed some. I think that's all of them. But let's look at this. I'm trying to get a positive 10 in the middle. There's two choices. So this is when I got to really focus and see that I'm also trying to get a positive 24. So to get a positive 10, here I'd have to take 12 minus 2. But if I multiplied those together, I'd get a negative 24. So 2 and 12 wouldn't work on this one. I'd have to use a positive 6 and a positive 4. So it'd be x plus 6, x plus 4. And then on this one, I'll put my x's down. It's always my first step. I'm trying to get a negative 10 and a positive 24. So this would have to be minus 6 minus 4. This time I'm trying to get a positive 2 in the middle. So that would mean I can do a positive 6 and a negative 4. And this one I'm trying to get a negative 2. So I can go x minus 6, x plus 4. If c is positive, what do you notice about the signs of both factors? So remember that c is my last term. So if c is positive, here's one where it's positive, here's one where it's positive. Let's look at my factors. I have two factors that are positive here and two factors that are negative here. If this one's positive, I have two that are positive, and then this one, they're both negative. So what I notice about the factors is that the signs are both positive or both negative. In other words, they're the same. If c is negative, what do you notice about the signs of both factors? So let's look. If I have negative 15, then I have a positive 5 and negative 3. Here I have negative 15 and I have a negative 5, positive 3. Down here I have a positive and a negative and a positive. So that means in order to multiply the last two numbers together and get a negative, the signs have to be different. Because the only way to multiply together to get a negative is if I have one negative and one positive. That's the only way that that would work. This is not something you have to know right here. It's just something that makes things a little bit easier if you recognize this property when you do it.